This question is from GATE 2018 Mechanical Engineering paper set 1, question number 41. A slider crank mechanism is shown in the figure. At some instant, the crank angle is 45 degree and a force of 40 Newton is acting towards the left on the slider. The length of the crank is 30 mm and the connecting rod is 70 mm. Ignoring the effect of gravity, friction and inertial forces, the magnitude of crankshaft torque in Newton meter needed to keep the mechanism in equilibrium is dash. Let's find out. So this being the crank, it is having a length of 30 mm. For the connecting rod, the length is 70 mm. This angle that the crank makes at this instant is 45 degree. Let this angle be beta. Now we have to do some construction in order to find out the torque. So torque will be given by the force component that is perpendicular to the crank rod. Let this force be Fp, that is force perpendicular to the crank rod. This into 30 mm will be the torque. So we have our torque expression as Fp into 30 mm, but we need it in Newton meter, so we'll convert this to meter right away. So torque will be 0.03 Fp in Newton meter. Now we need to find Fp in Newton. Now we'll do some construction and give names to all the points first. So this being point A, let this be point B and this be point C. At C we see there is a force acting 40 Newton. We can transfer this same 40 Newton force to point B. So at point B we will have this horizontal force of 40 Newton. We can find out FBC as 40 upon cos beta. So this actually we have got using the resultant vector diagram. We can draw it at point B. So we have at point B the forces are this force Fp, which is perpendicular to this crank. Then we have FBC, which is along BC, and this 40 Newton force is horizontal like this. So FBC, if we complete this vector diagram here, FBC can be written as 40 upon cos beta, because this angle is beta. This angle is 45 degree. Now to find force Fp, we can draw a vector diagram like this. Now magnitude of this vector that we see here will be equal to Fp itself, and this vector can be written as the force FBC. We can write Fp equal to force FBC into sine of this total angle, because this is the opposite side. So this will be sine beta plus 45 degrees. Therefore, we can write down Fp as, substituting FBC, 40 by cos beta. So 40 into sine beta plus 45 divided by cos beta. Now our job is to find out beta. Beta can be found out using sine rule. So by sine rule for triangle ABC, we will have opposite side 70 divided by sine of the angle opposite to it, 45 degree, will be equal to this side AB, which is 30 mm, upon the angle opposite it is beta. So we have upon sine beta. From here we will get sine beta will be equal to 0.303, and taking sine inverse of this value, we will get beta to be 17.64 degree. Now putting this value of beta here, we will have Fp will be equal to 40 into sine 17.64 plus 45 divided by cos of 17.64. Calculating this in the digital calculator, we will get value of Fp to be 37.278 Newton. Putting this value here, we get 0.03 into 37.27. So we get the value of torque in Newton meter to be 1.118 Newton meter. Let's go back and fill in this answer. So the answer here is the magnitude of crankshaft torque in Newton meter needed to keep the mechanism in equilibrium is 1.118, but we have to write the answer correct to 2 decimal places. So let's round it off 1.12. To learn more about balancing of the single cylinder machines, you can refer to the NPTEL video, Module 4, Lecture 1, Balancing of single slider machines. This lecture is from the course Dynamics of Machines. The course is taught by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope the solution will help you clear your doubt. Thank you.